All right, the third video, we are just going to talk about one specific thing in this video, and that is why are vertical angles congruent? Okay, so we've talked about vertical angles before last semester, that vertical angles were angles that were opposite of each other when two lines crossed. Okay, so angles 1 and 3 here, they're vertical angles, and 2 and 4, they're vertical angles. So we, for the most part, talked about first semester in the first chapter, just the identifying aspect of vertical angles. Like, hey, these are vertical angles. And we talked about very briefly that they really are equal. We can set them equal to each other. But now what we're going to talk about is, well, why are they really congruent? So we're going to do a proof for why vertical angles are congruent. So here we go. Here's our given information. We've got vertical angles. Sweet. What does that mean? We need to prove that vertical angles are congruent. So I just used angles 1 and 3. I could do this same exact proof with angles 2 and 4 instead, and just substitute 1 with 2 and 3 with 4, and it's really the same exact thing. All right, so the key to any proof is we need to start off with our given information. And our given information, I'm just going to rewrite this, is that angle 1 and angle 3 are vertical angles. And I'm going to use some abbreviating here, which is fine. And I know this because it's my given information. Sweet. All right, what can I do with this now? Well, I need some helper angles here, and that's where angles 2 and 4 are going to come into play. And really, I just need one of those. So let's use angle 2 as my helper angle. Now, to be able to show that 1 and 3 are equal, I need to use 2 as kind of like a middleman. So let's think about what's true about the relationship between angles 1 and 2. Well, let's see, 1 and 2, they're on a straight line, so angles that are on a straight line always add up to be 180 degrees. So I can say that angle 1 plus angle 2 equals 180. And why do I know that's true? Well, that's because of that thing called the straight angle postulate. All right, sweet. Now what? Well, now let's talk about angle 2's relationship with angle 3. Because again, remember, 2 is our middleman. It's going to be able to connect together 1 with 3. Well, 2 and 3, same thing, but we're talking about this line instead. Okay, so angle 2 plus angle 3 equals 180. For what reason? The same thing as before, the straight angle postulate. All right, so I have two pieces of information, but I really need to combine this into one. So there were certain things that allowed us to combine multiple pieces of information into one. So here's where we can do one of two things. The first thing I notice is, what do both of these two pieces of information have in common? And by in common, I mean on the same side of the equal sign. So don't just say, oh, well, they both have angle 2 in common. True, but all of this side and all of this side don't match up exactly. There are pieces of the left sides that match up. But I notice that the right sides of both equations are exactly the same. They're both equal to 180. So what could I substitute in for this 180 that 180 is also equal to? Well, this 180 is equal to angles 2 and 3. So I can take this and substitute it into that 180. Okay, so what I can really write here now, let me get rid of some of my arrows, is that angle 1 and angle 2, so I'm just taking this line right here, but instead of writing 180, I can write what else 180 is equal to. So it's kind of like I'm wrapping around here with these two pieces of information. So 1 and 2 are the same thing as 2 and 3. So we can call that the substitution property of equality, but it's also something else that we could call it. And I'll get there. Let me finish this last little bit here. Our goal is to get that 1 is equal to 3. And here's 1, and here's 3, and there's the equal sign, but there's only one thing standing in our way, and that is the angle 2's. But notice they're on both sides of the equation, and I can easily get rid of those. So if I subtracted angle 2 from both sides, I would end up with angle 1 equaling angle 3. And to do that, again, we had to use the subtraction property of equality. And we would be done with our proof. We just showed that angle 1 equals angle 3, and those are vertical angles. So vertical angles are equal. They are congruent. Now, one thing you might notice is I said we want to prove they're congruent. I show that they are equal. We're just going to say potatoes, potatoes. It's really the same thing. Now, Let me backtrack 1 second here. Back to this part. I said there's another reason we could have used besides the substitution property for why angle 1 plus angle 2 equals angle 2 plus angle 3. Let me rewrite it this way. Let me move everything up temporarily. If I said angle 1 plus angle 2 equals 180, and now I'm going to take this line right here and write it kind of backwards, if you will, and 180 equals angle 2 plus angle 3. So if this is true, which it is, then what can I conclude? Well, this is looking like the transitive property of equality. Here's our middleman, that 180 and 180, so what can I conclude is that the first part, this 1 and 2, must be equal to the last part, 2 and 3. And so angle 1 plus angle 2 is the same thing as 2 and 3 added together, because they both equaled 180. So what we could put instead of the substitution property, and I don't care which way you go here because technically both ways work, is we can say this is the transitive property of equality. And then we could have finished it out and said that angle 1 equaled angle 3 using the subtraction property of equality. And we could also be done there. So anytime you use the transitive property, you technically could use the substitution property. Does that mean every time you use the substitution property, you can use the transitive property? Not so much, okay? But just know the transitive and substitution work as the reason in both cases here. And that's it. I just wanted to show you guys why, how could we do the proof to show that this really is true. Now, this is the first proof that we've done that wasn't really algebra where we were solving for x in the end. This is what a lot of the geometry proofs we're going to be doing this chapter and in future chapters are going to look like. It's really going to be a lot of not really having many numbers involved. Instead of, we might have some 90s, some 180s and stuff like that. But beyond that, everything else is going to kind of be variables. Because I didn't tell you how big angles 1 and 2 and 3 were, but we use them as variables essentially. Okay, instead of 1, 2, and 3 for the angles, I could have called them A, B, and C. And so then it feels more like real variables instead of numerical variables, if you will. So that's all for this video. We will discuss more in class tomorrow, and we'll see you then. That's all for video 3.